So good evening. You just took the applications for Chapter 5 quiz earlier today. Now what we're going to talk about is Chapter 3, new chapter, Systems of Linear Equations and Inequalities. We're starting at Chapter 3, Section 2, Solving Linear Systems Algebraically. What is a linear system? A linear system is more than one equation, and I'm trying to find the answer or the answers to this equation that answers all the equations in that system. Today, well, right now I should say, we're going to use the substitution method. Substitution means I want to take one of my equations and solve for one of my variables. If I look at my equations, I realize I have an x by itself in the second equation. That's really nice. So what I want to do is I want to get that x by itself. I'm going to subtract 2y to both sides, and you get x is equal to negative 2y plus 2. I know it's odd, we don't always or normally never solve for x, but the thing is this, I've got x, and over here I have an x. I'm going to take the green x and put it into the black x and solve for y, because now I have 3 times, in parentheses, negative 2y plus 2, close parentheses, plus 4y is equal to negative 4. Right there, what I've done is I've substituted negative 2y plus 2 in for x. Why? Because they're equal. Since they're equal, I can substitute and solve. At this point, I'm going to distribute the 3. You get negative 6y plus 6 plus 4y is equal to negative 4. I'm going to combine like terms. Negative 6y plus 4y is negative 2y plus 6 is equal to negative 4. I'm going to subtract 6 from both sides. You get 2y, negative 2y, is equal to negative 10. That's a 10. We're going to divide by negative 2. So y is equal to 5. That's part of my solution. That's part of my answer. Y is equal to 5. But remember, we started with an x and a y, so I have to define x now. Now, the nice thing is I have this equation up here where I can say that x is equal to negative 2 times, I know that y is 5 plus 2. So x is equal to negative 10 plus 2. So x is equal to negative 8. I have the two parts of my solution. I like to write the answer as a coordinate. Please write your answers as a coordinate. And I have negative 8, 5 as my solution. Always remember, however, I can check my solution, plug it back into both equations, and see if it makes a true statement. If I look at the first one, 3 times negative 8 is negative 24. 4 times 5 is 20. Negative 24 plus 20 is negative 4. It's a true statement. Over here, if I said negative 8 plus 2 times 5 is 10, negative 8 plus 10 is 2. I can just look through and realize that those are good solutions. It is a good solution for both equations. That is my solution for the system. That's what we're going to be doing, finding usually the solution for both equations. And sometimes we can find multiple solutions. Sometimes we won't find any solutions, and we're going to have those today. So what's another way I can solve? I first started solving by substitution. And when I can put one variable by itself very easily, substitution is the method I want to use. However, the next method, and all of this should be reviewed from Algebra 1, is linear combination. Linear combination comes up when it's not easy to get an x or a y by itself in either of the two equations. So I look at these two and I notice something. I notice that I have a 2x and a 4x. It's not hard or not difficult to make this 2x be the opposite of that 4x. And the whole purpose of linear combination is to combine, add the two equations so one of the variables cancels out. Since I have a 4x positive, I want to make this 2x negative. So I'm going to multiply this by a negative 2. If I multiply by a negative 2, I'm going to get negative 4x plus 8y is equal to negative 26. That's my new first equation. I multiplied both sides by the same thing, and it didn't change the equation at all. My second equation stays the same. 4x minus 5y is equal to 8. Linear combination means I'm going to add these two equations, and this is the whole goal. I have a negative 4x and a positive 4x. When I add those, they cancel. They become 0. So I can then go 8y minus 5y, and I get 3y. Negative 26 plus 8 gives me negative 18. I have an equation where I have a y by itself. Excuse me, I have the 3 I need to get rid of, but I can solve for that y by dividing both sides by 3, so I get y is equal to negative 6. Again, there's part of my solution, but not my entire solution. At this point, I need to pick one of the two equations, it doesn't matter which one, and plug y in for it. If I pick the first one, I have 2x minus 4 times negative 6 is equal to 13. So I have 2x, negative 4 times negative 6 is positive 24. That's equal to 13. I'm going to go ahead and subtract 24 from both sides of my equation. I get 2x is equal to negative 11. Divide both sides by 2, and I get x to be negative 11 halves. There's the second part of my equation. So if I write it as a coordinate, my final answer is negative 11 halves, comma, negative 6. Again, I want to check my solution. I want to plug these back into x and y and make sure they're correct so I know that I have the right solution. I could also write this, of course, as negative 5.5, comma, negative 6. Either of these two would be my solution as a coordinate, which is what I want to write my solution as, but that's my answer. I can do substitution or linear combination. Let's try another linear combination. So on the first linear combination, I was able to multiply that 4x by, the 2x by a negative 2, so I got a positive 4x and a negative 4x. Here again, it's not easy to solve for one of my variables, so I want to try to do linear combination. The problem with this is there's not an easy thing I can multiply by. I can't multiply 7 by something and get 5. I can't multiply 8 by something and get negative 12. It's not going to work out really nicely. So what I have to do instead is I want to multiply both equations by a number, or by different numbers, so I get the same x value or y value. I'm going to choose to cancel out my y values. And I think about what's my least common multiple of 12 and 8. The LCM, least common multiple of 12 and 8, is 24. So I have to multiply my left equation by 2 and my right equation by 3. On the left, I'm going to get a negative 24. On the right, I'm going to get a positive 24, and those will cancel out. So the left equation, 2 times 7x is 14x. 2 times negative 12y is negative 24y. 2 times negative 22 is negative 44. That's my first equation multiplied by 2. Nothing's been changed. I just multiplied both sides by the same number, so they are still identical. Second equation, 3 times negative 5 is negative 15x, of course. 3 times 8y is a positive 24y. Again, I end up with my positive and my negative, so I know my y's will cancel. 3 times 14 is going to be 42. At this point, I can go ahead and add. If I add down, 14x minus 15x gives me negative 1x. The y's cancel the way I wanted them to do. I planned for them to cancel. Negative 44 plus 42 is negative 2. Multiply or divide both sides by a negative 1. I get x is equal to 2. There's my x coordinate. I now need to find my y coordinate. Pick one of my two equations. Does it matter which one? No. I'm going to pick the second one. So negative 5, let's do a different color. Let's do red. So I have negative 5 times my 2 plus 8y is equal to 14. Negative 5 times 2 is negative 10 plus 8y is equal to 14. I add 10 to both sides. 8y is equal to 24. Divide by 8. And y is equal to 3. So I get the coordinate 2, 3. Again, plug it into both of my equations, make sure it works. 2 times 7 is 14. 3 times 12 is 36. Negative 36. 14 minus 36 is negative 22. 2 times negative 5 is negative 10. 3 times 8 is 24. Negative 10 plus 24 is 14. So my solutions work. I have my answer. And that was linear combination. So let's see what I would do here. So let's go back, and example 4 says solve the linear system. I'm not saying solve it one way or the other. You can kind of choose which one you want to do best, which one you prefer. I'm going to solve it both ways. So the first way, I'm going to go ahead and say, hey, I've got an x by itself, so I'm going to add 2y to both sides. So I end up with x is equal to 2y plus 3. I'm going to plug it in for my x over here on the right, and I'm going to get 2 times 2y plus 3 minus 4y is equal to 7. Again, I have one equation with one variable. I can solve for it. Distribute the 2. I get 4y plus 6. That's distributing the 2. Let's use a different color. Minus 4y is equal to 7. Combine like terms, 4y minus 4y is 0, so I get 6 is equal to 7. Wait, that's not a true statement because 6 does not equal 7, so according to substitution, there is no, this is not true, so there is no solution. And I came up with a false statement. 6 is not equal to 7. 6 equals 7 is not a true statement, so this cannot be true. Well, what happens, what does it look like if I did the other? Instead of solving by substitution, I solve by linear combination. Well, linear combination, I would multiply the first equation by a negative 2. So then, let's scoot this over so I have a little room. So I'd have 2x minus 4y. Ignore that, Bell. This is negative 2x plus 4y is equal to negative 6. I multiplied by negative 2 so that my x's would cancel. And just like I wanted to, 2x minus 2x is 0. The problem is my y's also cancel. Negative 4y plus 4y is 0 as well. 7 minus 6 is 1. Again, this is not a true statement. Not true. So there is no solution. It doesn't work. And so what does this mean? That means the slope of these two lines are identical. I have two lines that are parallel, and they never intersect. Since they never intersect, I'm never going to have a solution. That's the type of problem that we have here. If I come up with a false statement, a statement that's not true, there's no solution because the two lines are parallel. Well, what's the other possibility? Well, let's solve this one. Again, solve the linear system. Let's go ahead and solve this using linear combination because there's no easy way to get one variable by itself. Let's go ahead and cancel out my x's. If I'm going to cancel out my x's, I'm going to multiply the left side by 5 to get 30. And I'm going to multiply my right side by 2 to get negative 30. So 5 times 6 is 30, minus 5 times negative 10y is negative 50y. 5 times 12 is 60. My second equation, 2 times negative 15 is negative 30. That's an x up there, and that's an x here. 2 times 25 is a positive 50y. 2 times negative 30 is negative 60. Again, if I go and do linear combination on this, 30x minus 30x is 0. Again, my x's canceled out the way I wanted to, but I also am canceling out my y's. Negative 50y plus 50y, again, is 0. But here, 60 minus 60 is 0. So I get the equation of 0 is equal to 0. That's a true statement. Since it's a true statement, not only do I have one solution, but I have infinitely many solutions. Any numbers that I choose to plug in for x and y, I'm going to get a true answer. So there are infinitely, make sure I spell this correctly, infinitely many solutions. Any numbers that I choose to plug in for x and y, it doesn't matter. I'm going to come up with a true positive solution. Why does this look like? Because if I graph these two lines, they turn out to be one line. My x and my y's are all the same thing. For every x, I come up with the same y. Every point I choose is going to be on the same line because these two are actually the exact same line written differently. So therefore, every x I choose is going to give me a y that's on this line. So that's my solution. That's our problems for today. You will have stuff together in class today. For those of you listening to this, there will be a sub, so make sure you bring your book to class, and I will see you in a couple days.